All right, here we are, the last one. I have not the same thing to do literally the entire time this time. Okay, so we're gonna look at special right triangles from the Pythagorean Theorem. So here, think with me for a minute. If I have a 45-degree angle and a 90-degree angle in a triangle, what's the third angle? It's 45. This is one of two special right triangles that we have. We call them special right triangles. They are just ones that get used a lot. So our angles are 45, 45, and 90. And the side lengths that go with these, let's say I have one here. Let's say I call that side 1. Well, then what's that side? Well, since it's a 45, 45, we know this is an isosceles triangle, so this and this are the same side length. So what would our third side length be? Well, we could use the Pythagorean Theorem and say 1 squared plus 1 squared is equal to c squared. We're not going to use our calculator at the end here. Just in case you don't know, 1 squared is 1. So 1 squared, so it's just 1 plus 1. We get 2 is equal to c squared. And to find out what c is, we're going to take the square root. And we get c is equal to the square root of 2. And so the side lengths of a 45, 45, 90 are 1, 1, and square root of 2. And I put 1 is across from a 45, 1 is across from a 45, and the square root of 2 is across from a 90. So, and let's take this idea and extend it. Let's extend it to a bigger triangle. Instead of being 1 and 1 and square root of 2, let's look at a triangle that's 7 times bigger. Look, this triangle has a side that says 7. What would that make this side then? Well, we can see our hypotenuse is across from the right angle. This would be 7 as well. This is a 7, 7. It's 7 times that and 7 times that. So what's 7 times the square root of 2? Well, it's actually really easy. All we do is we write 7 square root 2. It's 7 times the square root of 2. So it follows this 1, 1 square root of 2. So a lot of times what you'll see is it's s, s, and then s root 2 for side length, side length, side length root 2. But I grew up knowing 1, 1 square root of 2. So, so look at this one. So what would this one be? Well, 12 root 2. I see 12 root 2. That's how we read that. We read it 12 root 2. Oh, it's across from the right angle. This is my hypotenuse. This is this piece over here. So what would the s need to be for this to be 12 root 2? Well, it would be 12, right? Because 12 root 2 is what we see written there. That means that this and this are both 12. And that's the 45, 45, 90 triangle. It's one of our two special right triangles. We see one side, we know all 3 sides. We don't have to do any Pythagorean theorem or anything, it's just something we know. Here's our next one. What are the key details of this special right triangle? Here's our other one. Well, if I have a 30 degree and a 90 degree, what's my third one that's left over? Let's find out. 60. So this is called a 30, 60, 90. And this triangle is as easy as 1, 2, 3. So I'm gonna start with 1 for my babyest side right now. And wait, which side is the smallest side? Well, I've got a 30 degree, a 60 degree, and a 90 degree. If you remember from previous chapters, the smallest angle is always across from the smallest side. So I'm gonna call this 1 right here. 30, 60, 90, I'm not gonna get into the full reasoning behind how this works. It was easier with the 45, 45, 90, but the 30, 60, 90, it winds up being 1, the square root of 3, and 2. It's very easy to mix this up. I always say this is 1, 2, square root of 3 in my head, but the problem is, what's the biggest side out of all these? The one across from the right angle. Look at this. Which one's bigger, the square root of 3 or 2? Square root of 3 is only 1.7. 2 is 2. 2's bigger. 2 is 2. Wow, why did I say that? Hey guys, did you know that 2 is 2? All right, so 30 goes with 1, 2 goes with 90, and square root of 3 goes with 60. And so it's this same kind of scale. I can be like, if I call this S, well, this is just, it's going to be double it, so we call it 2S, and this we call S times the square root of 3. And so we can very quickly look at a 30, 60, 90 triangle and know all the sides. So like in this one, I see this is 6. Well, I know the hypotenuse is going to be double it. I know the hypotenuse is going to be 12. And I know this one is going to be 6 with a square root of 3 tacked on. And that's literally it. That's how this works. So on this one, I see 9 root 3. Oh, okay. Oh, and it's across from 60, right? So that's this one. So what would the S be then? The S would be just the 9, and then the hypotenuse is going to be double it. It's going to be 18.
Some duct tape is back in here.
Oh, the students might have been using it.
Yeah. It's fine. I just need a... Oh, no.
Okay.
Are you tutoring right now?
I'm just filming a video for class.
Sorry if I interrupted you.
Nah, you're good. iPhones don't have a pause button. My old one, I could just pause it whenever I needed to. And
Oh, so they're just listening to this.
yeah. Mr. C says hi. All right, so we got 4 more. And all I gotta do is figure out the category and then just plop it into the thing. So like this is, I see 30, 60, 90. So 30, 60, 90 was 1, 2, nope, see, I do it wrong. The 2 goes with the 90 degree. 1, 2, square root of 3. So 10 is double our small side, so that's 5. And then 60 is our small side with a root 3. On this one, I see a 30, 60, 90, so 1, 2, square root of 3. What? 28 is equal to my small side times the square root of 3. Okay, that's a little tricky. Oh, okay. So here's the problem. What I'm gonna have to do to figure this out is I'm gonna have to go, well, my little side times the square root of 3 is equal to 28. So what's 28? Or what's the little side? We'll have to actually divide by the square root of 3. So we'll say this small side here is 28 divided by the square root of 3, and I'm fine if you don't leave it as 28 divided by the square root of 3, because we could actually leave it like this and call the big side 56 divided by the square root of 3, but instead we can use our calculator and get 16 so this is 16.6, or sorry, 16.2, and then we'll double that to get 32.3. All right, and I do want to go help Mr. C, but I just want to finish this up real quick. So let's look here. We'll start with this one. This one's the easier one. It's a 45, 45, 90. That's 1 square root of 2. So 5 root 2. That easy. This one, it's the same kind of thing as before. So 14 is, since it's across the street from our right angle, is our small side root 2. So we'll have to divide by root 2. So our small side is 14 over the square root of 2. And since like I can get the decimal if I'm uncomfortable writing this, but I can just go 14 over root 2. So I'm like, what is that, man? I don't care. Some number. 9.899. Cool, there it is. Woo. So that's what that is. Thank you for working with me today, and bye.